Yeah, we can begin. So today we're going to be doing linear algebra. So as you know, linear algebra is all about your matrices. So you're going to be doing your matrices. So basically, your matrix, it's an array with a set of numbers that are arranged in the rows and columns. Hence, you're going to find something that's going to be looking like this. You'll have your A, B, C, D, E, F, G, H, I. You see? So as I said, it's a rectangular array, as you can see, with a set of numbers that are arranged in rows and columns. So this would be what we call your rows. Then these ones are going to be what we call the other columns. You see, so that's the first thing that you have to note about your matrices. And we also have to note their size. Okay, if we have one that looks like this, remember how we read this. We read them as rows by columns, but you will see in maybe in your textbook they just call it your m times your n. So this one will be the rows, then this ones will be the columns. You see, so it's always like that. So when they want your size, they're actually just like referring to the rows by the columns. You see, for this one, how many rows do we have? We have 1, 2, 3. Then the columns, we have 1, 2, 3. So which means the size for a matrix, we have a 3 by 3 matrix. So as I said, this one would be your row, then this one would be your column. So that's that. Then if they won't ask you about the size, they will just like ask you about the positions of the elements. I'm trying to remove this thing. Okay, so let's just say, for instance, let me just give you an example with the real numbers. So let's just say we have something that looks like this. Perhaps they give you something like your 2 minus 3, your 0, your 1, your 1, your 2, your minus 1, and your 6. I'm just giving these values randomly. Then they've given you something like this, and they tell you to find, okay, let's just call this matrix A. So each and every time you see something like this where you have your A is equals to this thing, an array that like it's given with your entries, you just know that this one is your matrix A. So basically what you're saying is your matrix A is equals to this that you're seeing. Then whatever that's on the inside, we just like call this the entries, or you can just like refer to them as your elements. So basically these ones are what the elements of A or matrix A, or you can just like say it's the elements of your matrix A. So okay, if you have something like this, then if they say you have to calculate something like your, okay, let's just say you have your A 22, then you have your A 34, then you have your A 33. Then this is how you go about calculating. Remember, this can be written in the form that you have your A, which is going to be your I. I'll do it like this. Oh yeah, it's going to be your A, your I multiplied by J. Now, why is it doing this? Your I multiplied by J, or you can just call them your R multiplied by your columns. Remember, as I said, that we always have the RC, the rows by the column. Rows, columns, rows, columns, rows, column. This one just tells you that is your matrix A. So we go and check that, okay, on the first one we have a row 2 and column 2. So row 2, it's definitely this one. This is 1, 2, 3. Row 2 is this one. Then column 2 is this one. You go and check where they intersect. Row 2, you go here. Then column 2 is going to be here. You see, they intersect here. So which means your first answer is going to be 1. Then you go to the second one where they say you have to calculate your A of 34. That means you have to go to row 3, which is this one. Then you go to row 3, column 3. You go to where they intersect. You go and you see that the answer is this one. Then you write it down. Then the last one, they say you have a row 3. No, I even made a mistake. This is supposed to be the one for 4. I don't have a column 4. I don't have column 4, so this one is going to be the one for 3. Sorry for that. I don't have column 4. I only have up to column 3. So which one? This one is going to be 3. Then let's change this one and let it be 1. So I will also erase this. Okay, if we're going to consider the last one, it means we have to consider row 3, column 1. Row 3 is this one, then column 1 is this one. They intersect here, which means now this is going to be your 0. So that's easy 2 marks, which you can just like expect some of these questions in your multiple choice or section B. Then another thing, let me just check here if I'm not going to be missing anything. Okay, with regards to your scalars or your product, you can only multiply your matrices that like are of the same size, meaning you can only multiply let me do this. You can only multiply a 2 by 2 with a 2 by 2 matrix. So this would normally look like something like this. We have your 1 minus 2, your 3 and 4. Let's just call this matrix A. Your matrix B would be your 0, your 8, your 9 and 1. So that's basically what they are saying in terms of multiplication. And when you're going to multiply this, if you are multiplying your matrix A by B, it means now you're going to be having your AB, which is equals to, then you will have that 1 multiplied by 0. Then you're going to have that minus 2 by 8. Then that side you're going to, at the bottom, you're going to have your 3 by 9. Then you're going to be having your 4 by 1. 4 by 1. So now you know your A bit equals to your 1 by 0. This is going to give you 1. Then this is going to give you your minus 16. Then this one, it's your, I think it's 27. Then this one is going to be your 4. You see, this is basically how you go about doing your multiplication. And with the addition is just the same. It's just like you have to write your A plus B, then you add them together. You will go and say your 1 plus 0, which is going to give you your 1, then your minus 2 plus 8 minus 6, in that order. Then you just come and write them down other side. So let me just like find an example. I think I had an example that like analyzes these things better. Analyze these things better. As I said, okay, here we have the rows, here we have the column, and one other thing. Okay, what did I want to mention? Maybe I'll just like think about it when we're going. Okay, let me just go down. Put it this side. So we have an exercise 1, this side. So having an exercise 1, they say consider the matrices below. So we have matrix A, B, C, D, and E. The first question says write down the size of each matrix. You remember what I said about the size? We always have your rows multiplied by your columns. What's this here? Let's just study this work. I'll just do this. Okay, as I was saying, when every time we're determining the size of a matrix, we consider the rows by the columns. And as I said, it's typically your rows. Then this would be what we call your columns. You see? So now what do we have? We have the columns. Then this side we have the rows. Then here we have the rows. Then this side we have the columns. So remember, it's your rows times the columns. Then this side we only have a column. No, we only have a row. This side we only have a row. Then this side we only have a column. You see? So you're gonna go and try to write this down, that okay, for your A, you will go and consider that okay, for the first one you have your A, which is going to be written as what you consider the rows. The rows we had how many? It's 1, 2, as you can see in yellow. It's your rows times your columns. How many columns? By 3. That would be your size of your matrix. Then we go to B and we consider the size. We consider the rows by the columns. How many rows did we have? We have the ones that are in yellow, 1, 2, 3, 4. So this is going to be a 4 by 2 matrix. Then you'll see, you're gonna go and check how many rows do we have. This one you can just say it's a 1 by 1. Then the last one, also this one, you'll just say it's a 1 by 1. No, not a 1 by 1. That's a 1 by 2, because we have 2 rows. 2 rows. 2 rows. 2 rows. We have that one, which is the column. Then the rows, I'm just going to indicate it that we have a row 1, a row 2. So here we'll say we have our 1 by 2. So that's how you go about doing the first question. And as I said, where is my stylus? As I said, you always start with your rows followed by your columns. So these ones are your rows, these ones would be the columns. So
may I just ask?
Yeah.
For C, why is it not 1 by 3? And why is it like 1 by 1?
For C, 1 by...
Because it's got, I'm saying it's got 1 row, but then with the columns, why is
I
it
think
1?
Yeah, I made a mistake because we have 1. We have 1 2 3. I was just thinking about something else. Let me just see. Rows 1, the columns, that's 3, 1 by 3. So yeah, sorry for that. 1 by 3. Then the last one, the last one, I think I fixed it. Then we go and check number 2. They're saying which of the matrices are square matrix. So normally for your square matrices, you're going to have so you're going to have equal number of rows and equal numbers of columns. So like an example, that's exactly the thing I was thinking about. If you have something like your 1 by 1, 2 by 2, 3 by 3, those are ones are going to be your square matrices. So you go and check. Oh, we didn't even do one for E. Let's just quickly do one for E this side. We have BC. This one is for D. I need to focus. Then we have one for E. One for E will say we have 2 columns, 1, 2. Then the rows, we're going to have 1 and 2. So yeah, as I said, the rows it's 2, the columns it's 2. So that means here we're going to be having a 2 by 2. Hence you can even note that this one is going to be our square matrix since it has an equal number of rows and columns. So hence you can go and write for your B that which of the matrices are going to be square matrix. This one, your E, which is your 2 by 2. Then your C and your D, they're saying which one matrices are row vectors. Your row is basically going to be your C. Then which one of those are going to be your column? This is going to be this last one, your C and your D. As simple as that. Then let me just erase this. Let me see.
Sorry.
Yeah.
What do the terms row vectors and column vectors mean?
The column vectors, yeah, they just like are referring to your rows and your vectors. basically the one that you see that like it only has rows, and the one that you'd say it's represented in the form of a column. This one we've done it. Okay, let's just put it this side. Then moving this one, we can put it this side. Oh, not that one. Can you find all numbers are an S such that 8 and 1? This one, I think we've already done this one. Let me just go back and put this one this side. This one, it was just one of those examples where they wanted the product of R and S. So let's just say maybe you get something like this. I think I even forgot. I was supposed to send the other questions on the group, but like I'll do so. Let me just check something. Okay, yeah, I have them saved to that side. Then yeah, we'll just like go and do your 9. Okay, the other one we're finished with the one. I'll do this other one. I'm just thinking, okay, we still have to do the augmented matrices. After the augment, which other question do they like? Okay, yeah, I'll just like try to think of them along the way. I didn't try to at least maybe put them together this time, but like at this ones, yeah, I just like remember having to put the questions, and also yeah, with the one at the top, number 1, and they don't ask you like exactly what is your row vector or the last one. I'm just thinking of like a way I can try to explain this. The last one, you just know that okay, if they're saying something, it's a row vector. This is basically telling you that okay, if it's a row, it means your m is equals to 1. Then if it's a column, it means your n would be equals to 1. Hence, you have to remember that I said if I'm going to consider the size, I have my m multiplied by n. My m it's my row, then my n it's my column. So if I have my m which is equals to 1, it means in that instance I have a row vector, and if my n it's only 1, it means that matrix it's called a vector. Hence in number C you can see that okay, this one would be a row vector because your m is equals to 1. You only have this one. Then the one in D, you will see that your n is equals to 1 because you only have this column. So that's basically the only definition I could think about. So yeah, if you were to explain it mathematically, you can just like explain it like that. Then yeah, let's just continue with this question. So let's just say maybe you're given something or a question that says, can you find the real numbers R and S such that you have something that looks like this? as you can see, what they're basically doing this side, they're basically multiplying. You can see they're multiplying your R by this first matrix that you have, and your S by this first matrix that you have this side. So for our first question, let's say okay, let's just try and consider the right hand side for now. Okay, we're going to have something that looks like this. We have our R multiplied by the 1, the 0, the 0, and the 1. So what's this? It's going to give us your R multiplied by 1. This will give you your R multiplied by 0. This will give you your 0. Your R multiplied by 0. This will give you your 0. Your R multiplied by 1. This will give you your R. Then remember, we still have the S, and they're saying the S multiplied by what? Your 0, 1, your 0, 1, and 1, 0, and your 1, 0. This will give us your S multiplied by 0, that is 0. Then here you're going to have your S multiplied by 1, your S. Then your S by 0, then you're going to have your 0. Then if we combine this, remember we're going to have your R and 0, your 0 and R. We're combining these ones that we got this side. So we're going to be having this plus this one, which is going to be your 0 and your S and your S and your 0. So you will see that the final one that we're going to get your R plus your 0. This is your R, then this side your 0 plus your S is your S, 0 plus your S is your S, then your R plus 0. This will give you your R. So now we are done with this part. It means we just have to equate whatever that's on the right to whatever it's given on the left. Remember, on the left, what do we have? We have this 1 and 2, 3 and 4. So now this one is equals to, what do we have that side? We have R, S, S, R. We have our R, S, S, R. So this one, they're going to be matching one another. You see? So now you can say the top R, it's going to be equals to 1. Then the top S is going to be 2. Then the other one is going to be, it's going to be 3. Then your R, it's going to be 4. Then we have to check the second one. The second one, they're saying you have something which is similar, then you still do the multiplication for that. Can we just quickly try and also attempt to do this one as a group? Remember, as I said, the first step that you do if you have something like this, you multiply your R by these values that you see on the inside. Then you do the same thing with your S. You're multiplying it with these values that you are seeing. Then after doing that, you combine your R plus your S. Then your R plus your S, you equate it to whatever that's going to be on the left hand side. But now we're just going to be doing one for B. We do one for B, then I think like okay, in the next like 3 or 4 minutes, I'm just going to be sharing the final answer for this one. So yeah, you can also try it on your side. I'll try it on a paper, then give out the final answers quickly this side. So yeah, I also hope that like you guys have your papers, because like now we're just like having a session and practicing at the same time. Okay, I'm already done on my side. Then yeah, we'll just like share the answers around 22, which is like 2 minutes. Okay, yeah. Do you guys have the answers for me? What did you guys get? Anyone that wants to try it out? Ale brave, ale brave. Okay, I'll just like do it, then like you'll see where you got it wrong. Remember, the first step you have to consider what's on the right hand side, which is basically this portion here. And as I said, you're quickly going to be multiplying your R by your first matrix or your arrays. Then same thing with the S. So it means what are you going to have if you're going to multiply that? Going to get your R, your 0, your 0, your R, then plus into your 0, your S, your 0. Then this, when you add them together, they're going to give you what? You're going to have your R as this side, your S, and your R. Then you equate this one to this one that you see this side. So now what do you have? You have this one, your 1, 2, your 3 and 4, which is equals to this one that you have worked, your R, your S, your S, your R. So the final one, you will say your R is equals to 1, your S is equals to 2, then your S is equals to 3, then your R would be equals to 4. As you can see from this side, I'm just checking that, okay, your 1 is going to be going with this one is going to be going with this one is going to be going with this one is going to be going with this one. So this is basically what you're supposed to do when you get something like this. Then you will see, I think I've seen one, was it like one final exam? But like, yeah, as I said, some of the questions I'll just like send them on the group so that like you guys can also get to attempt them and see what stuff asked in the exam. Okay, we've discussed this so far. Okay, we've discussed the matrices and their signs. Okay, let me just like write them down here so that you remember. So we said if B is an M times N matrix, then the size of B is M times N. That's the first point. Then if your M is equals to N, this is what I said about like your rows being equals to your columns. Then we will say the matrix, it's a square matrix. So the third one, we said if your M is equals to 1, then your matrix, this one will be called your row vector. Then the fourth one, we said if your N is equals to 1, then the matrix would be called a column vector. So that basically sums up what we've discussed at that side. And the other one, it was just mainly about the product rule. The product rule and the addition rule, which we've done somewhere along here. Then, okay, I'm just thinking, am I missing something? Because like I know the last one that like we're supposed to do, it's your augmented matrices. Okay. Yeah, I think now we can go to augmented matrices. Perhaps I'll just like think about the others as I'm busy working through these things out. So you will have something like a linear equations, which it's like your 3 equations that are going to be given to you in the semester test. Probably because like I've seen, they said in your, what's that? Yeah, your linear algebra, if I'm not that mistaken, it's about 15 marks. And I know about close to 7 to 8 marks will be based on that one. You will get like your 3 linear equations that like you have to solve for your x or y, z. This will be around that 6 or 7 marks. Then the others will just like be just like few small questions based on linear algebra. So these are the type of questions that we're gonna try and tackle them now. So without wasting time, so we're gonna go to your augmented matrices. You're gonna have your augmented augmented matrix. So these are basically what we're going to be doing together with your linear ones. So let's just say you have your matrix A, which I'll just give it as your 1, 1 and 2. Then you have your matrix P, which can be written as your -2, 3, 0 and 1. So if we want to write this in an augmented form, we simply note it by creating or joining the columns of two matrices. And remember what I said, these ones are your columns, you see. So your augmented matrix for A and B, let me just say for A and B would be something that looks like this. You would have your A slash your B, you see, which is going to be looking like this. Basically, you are joining them together. On your left hand side, you have that 1 and 2. Then you have this line in between. Then you now go and write your second matrix, which is your -2, 3, 0 and 1. This line that you see in the middle, this just shows you where the one half of the matrix ends and where the other one starts. Remember, this side we have your A, and this side we have that B. You see? So these are now in augmented form. So yeah, also if we have written this in augmented form, it is just helps us to solve two matrices at once. Hence we also use it to solve a system of linear equations. So now I'm gonna go and at least try to solve an example which perhaps you're going to get in the exam. So let's just say now you have your x plus your y plus your z. This one would be equals to 3. Then this side you have your 2x plus your 3y plus your 7z. Please note this one, it's a z. Your 7z, this one will be equals to 0. Then this side you have your x plus your 3y minus your 2z. This would be equals to your 17. So yeah, this one, it's quite easy, but yeah, you just have to make sure that you are able to manipulate this whole system. So on your right, as you can see, we have what we call the constant. Then on the other side, which is your right, you can see we also have your coefficients, which are mainly these ones that you see. Remember, here we have 1, this side we have 2, here we have 3, here we have 7, here we have 1, this side we have your 3, then this side we have your 2. See? So if I'm going to be writing this in an augmented form, I will say I have my 1, then you have your 2, your 3, then you have that 7, you have that 1, you have that 3, then you have that -2, then you write that line and show that this is where the first part ends. Then this side you have your 3, your 0, and your 17. So this is how you're going to write that in augmented form. But now the second step, when we are going to be solving our system of linear equations, how I like to note it is that, okay, if we have something that looks like this. So what's the size for this? This is a 3 by 3 matrix, rows by columns, 3 by 3 matrix. So let's just say we have something that looks like this. So how I like my matrix to look like, we would have our 1 1 1. Then here we're supposed to work it in such a way we have a 0 this side, a 0 this side, and a 0 this side. Here we can have any number. Okay. Yeah, any number. We just have to make sure that, like the triangle at the corner this side, we have worked this one, so manipulated the equations in order that like we get our 3 zeros this side. Or the second step that I also like to use, we can at least try to ensure that we have, I think I'll just like use similar values. We have 1 1 0 0 0 3 minus 2 4. So now in this instance I have my rectangle on this side. See, so this is where you can just like try to make sure that like you manipulate your equation to give you your zeros, then you end up solving the equation. In essence, what we are trying to do is that like, okay, since we are given these 3 equations, what we now have to do is to make sure that okay, now the only ones that we have to replace and make sure that they are 0, it's going to be this one, and this one. So it means we have to end up in such a way that we have something that looks like this. Okay, it's like this. We're going to have something that looks like we have that 1 1 1, then we're going to have that 0. Here we'll have the 3, the 7, the 0, the 0, the minus 2, and this side we're going to have the 3, the 0, the 17. So if it's like this, it now means we can be able to solve our x and y's. Remember, if it's like this at the top, what do you have? You need to remember that here we have that x, this side we have that y, then this side we have our z's, you see. So, and if it's like this, it means now in this example we're going to be having something like your 13z or your minus your 2z. Remember, as I said, here we have your x, y, z. It means now we have something like your minus 2z is equals to your 17. Then we start solving for your z and your x. Then now when you come to the second step, which is going to be this side, you're going to be having your y, your y plus that z, your y plus your 7, which is equals to 0. But like you'll see as we get there, I don't want to confuse you with these ones. Let's just solve it step by step. I just wanted to explain how the entire process goes. So now we've written this thing like this, and our first step, we are done. We've written this in an augmented form. We've only taken out the coefficient that okay, we have 1 1 1 1. Then on row 2 we have 2 3 5. The third row we have 1 3 5. So okay, we go and look at this. Let me just like remove this. And remember, our end goal is to make sure that like we're getting a 0. Perhaps let me just like leave them so that you can remember where where we have to have our zeros. Our end goal is to ensure that like wherever you see where I've circled the numbers in black, this is where we're supposed to be having our 0. And remember, this one, it's your row 3, this one is your row 2, this one would be your row 1, and this one will be your column 1, column 2, column 3. Column 3. Then now we're going to start with the calculations. First we go and check that, okay, what can we do to ensure that our row 3 is 0? Because now what we're basically doing, we're going to be working with elimination. We can eliminate, and at least maybe no, you guys are not doing the swapping. In this case, we're going to do the method of elimination. So if you can see, if we want to make sure that like we have a 0 where we have our 1 here, we will say our new row 3, I'm just gonna write it in capital letter so that you're not confused. Then the ones that like are also present, I'll just like leave it with the small letters. So if I want to ensure that like that 1 becomes 0 by using the method of elimination, I will say I can consider my row 1 and row 2. You obviously can see that, okay, if I deduct 1, then I'll be able to get like a 0 this side. Hence, you can say you will have your minus row 1 plus your row 3. So if I have my minus, okay, let me just do it this side. So we're going to be doing it step by step. So you will see your row 1. If I have minus 1 plus 1, this will give me my 0, which is what we're looking for in this. Remember, I'm using this equation that like I've created here. So it means now here you're going to be having that 0. So now you're gonna go and check minus your R1, which is going to be what? You go to your second column, then you will say minus your R1, you're going to have your minus 1 plus your 3. Then this one will give you what? Your 2. Then you go and write your 2 this side. Then okay, you will come again and say you're gonna go to column 3. Then you will say you have your minus 1, which is the one this side. You have your minus 1, then minus 1 minus 3, not minus 3, minus and minus 2, not minus, minus plus into minus 2. Then this one will give you your minus 3. Remember, we have minus R1 plus R of 3. Our minus R1 is this one, then R3 is going to be this one, then this one is going to give us minus 3. So it now means we are done with row 3. We're trying to change our row 3. So now we've managed to find how to change our first value, which is our 1, to 0. So which means we're already done with the first one. We can concentrate on the other one. So we've managed to change this one. Remember, we were only working on row 3. Let me just like leave it this side just to show that okay, we were working on row 3, which is equals to minus row 1 plus row 3, it's going to give you this. Then remember, row 2 we didn't change, we just write it the way it was. Then we're going to have a 2, 3, 7. Then at the top we had 1, 1. Then we still have that 1. Then here we have 3 and 0. We have 3 and 0. What we forgot to change this, the last one, which is our 17 this side. So we're just gonna quickly go and do it. That we have minus row 1, which is going to be minus 3, which is going to be this 3 at the top, plus into our 17. Then this one is going to give us 14. So which means now we're going to be writing the 14 this side. So it now means row 3 now, we're already done with it for now. So now we go again and check from this one. Now we have to ensure that like these ones that you see here, these get to be 0 as we've indicated. So in order to ensure that this one, the order that I like to use, I normally start with this one at the corner, then go to this one, then go like this. It's like I'm going in this way, hence I'm just saying you're going to have the triangle at the corner, or the other triangle like this if you're going to be having your 0 here, here and here, as I've indicated in that other example. So if we have an example that looks like this, now we are trying to manipulate your row 2 because you're trying to change this 2 here and ensure that it's going to be 0. So you now know that okay, whatever that you're doing, you have to do it on your row 2. So you can see that if you multiply your row 1, remember here we have your row 1, this side it's your row 2, then this side it's your row 3, then the other side it's your column 1, column 2. If we multiply the row 1, then we add the row 2, we're definitely going to be getting a 0 when we're getting to that 2. So how is that gonna look? Let me just do it in this way. That okay? Remember we're only working on number 2, so it means you can even go and simply just write the other ones that you got, because these ones are not going to be changing. The only one that is going to be changing is your row 2. So you can just quickly go and write it like this. Then you go and check that okay, you have what are you going to have? You have your minus 2 into row 1, so which is going to be minus 2 into row 1, which is going to be 1, plus your row 2, which is going to be 2. Then this one is going to give you a 0, which is going to be this side. Then you're going to have what? Why am I minus 2 into row 1? I want this thing. Then now you're gonna go again and say you have minus 2 into 1 plus 3. Remember from the formula, then minus 2 plus 3, then this is going to give you 1. Then you go and write your 1 this side. Then you may erase this, that you have your minus, what do you have? you have your minus 2 into row 1. Then you're going to have that one plus into your 7 minus 2 plus your 7. This one is going to give you your 5. So now it means you're going to be having that 5 this side. Then you go and consider the last one. That okay, what do you have? You have your minus 2 into your row 1 column, the last column. Then means now you have your 3 plus your 0. So it means now you're going to be having your minus 6. Then this side you have your minus 6. You have your minus 6, then we are already there. You can see that like so far we've managed to find the 0 this side and this side. The only part that's left is this one where we have our 2. Then with this one you can already see that our row 3 or a new row 3 that we're going to have, what are we going to say? We're going to consider a row 2. You see, if we multiply the row 2, which is this one, by 2 or negative 2, then we add it to row 3. It means we'll be able to get the 0 at the bottom. So I'm basically saying we have minus 2 times row 2, which is this one that you see, plus the row 3. So what are we going to be having? We're going to be having something that looks like this. Then remember, as I said, now we're working on row 3. The other ones we can just like write them the way they are. We have 3, we have 0, we have 1, we have 5, we have minus 6. Then now we are currently working on that one. Okay, let me just add a page. Okay, I'll just like do the calculations at the bottom. Then what do we have? We're going to have minus 2 into what? Into your row 2 is going to be your 1, which is that one that you see this side. Then we add it to row 3 plus your row 3. But do you have your row 3? You have that too. So this one is going to give you a 0. Why am I starting that side? Okay, I made a mistake. I started exactly at 2. Let me just start at the corner. Apologies for that. Remember I said my row 3 is equals to my minus 2 row 2 plus row 3. So we're going to be starting at this side. We will say we have minus 2 into row 2 as 0 plus 3 to 0. Then this one will just give us a 0. This will just give us a 0. So we go to the second one where they say we're going to have minus 2 into what we have in row 2. We have that 1 plus the 2 in row 3 that you see that side. Then we have minus 2 into 1 plus 2. This one will still give us the 0. So now we have this 0 this side. Then we go to this one. We have minus 2 into what we have in row 2. We have 5 minus 2 into 5 plus into row 3. We have our minus 3. Then Okay, it means now we're going to have minus 10 minus 3. This one will give us minus 13. So this side we're going to be having minus 13. Let me just erase this and write the final one that side. Then okay, on the other side what are we going to have? We have minus 2 into minus 6 plus minus 10 to minus 6 plus your 14. Then this is equals to your 12 plus your 14. Then this would give you your 26. So this side you're gonna go and write your 26. So now what we have that augmented form that we wanted to have. Hence we can go and say, okay, we have managed to work out that triangle of zeros that we wanted at the corner. So now we have those three that you wanted. Then you have to go again and check that, okay, remember what did you have? You have your x, y, and z. So you can quickly go to this one and say, here I still have those x, your y, your z. So we're going to start with the last one, since it's just simple to work with. You will say you have what do you have? You will say you have your minus 13z. Remember, it's your z at the top and this. So if you want, it's the same as here, bringing back these things down, but now we're just like keeping that side because like we just wanted to write it nicely in an augmented form. Then this would be equals to your 26. Then this means like your z is going to be your 26 divided by your minus 13. Then your 13 goes into 26 two times. This would be equals to your minus 2, which means now we've already worked out the first value for z. Then on the second row, what do we have? We have the y, the y plus 5z. As you can see, you're gonna have your y plus your 5z is equals to what? What is that? Your y plus your 5z is equals to your minus 6. But we've already worked out your z, that is minus 2. You will have your y plus your 5 into your minus 2. This is equals to your minus 6. So this is the same as having your y minus 10 is equals to your minus 6. Then you will have your y is equals to your minus 6 plus your 10. We'll add a page. So it now means your y would be equals to your 4. Let me just do this. Your y is equals to 4. Your z is equals to 2. Then you go and check the last one, that okay, what do you have? The one at the top, you have 1 1 1. This means you have your x plus your y plus your z, that's equals to 3. Then as indicated, what did I say? We have the x. Now I want to return back. We're going to have the x plus the y plus the z. This would be equals to your 3. Then your y, you've already worked it out, that okay, we had the 4. Then the z, it's already worked out that it's minus 2. So this basically means what you have your x plus your 2 is equals to 3. Then your x is equals to 3 minus 2. then your x will be equals to your 1. So it now means you have solved why is this not changing? You have your x, you have your x, your y, your z. This is equals to your x is 1, your y it's 4, you have your 1, your 4, your minus 2. These are those answers that you got. Then you get your 7 marks for that one. You get your 7 marks for that one. The other one, what did they ask? I think I saw a question where let me just check here. I think I wrote it down. Didn't I write it down? There was like this interesting question that I saw. Okay, let me just quickly check the questions on my phone. If I'm not missing it out, did I send it to the thing? Okay, I'm also charge this. Where's that question? Oh, I see. This other one that like I have to address. Did I save it? Okay. Okay, let me. What's the question? Okay, perhaps I think I'll just like see it and include it in the next session. I'll also send you guys some of the questions. Is it this one? No, it's this one. I just wanted to at least maybe show you any way that they could ask you some. I see there was like one question in one of the questions, the past papers. It was something like this. Okay, what were you given? You were given something like your 2x1 plus your 4x2 plus your 2x3, that's equals to 0, not your z. Yeah, it's equals to your 0. Then you have your 4, not your 4 but your 3. You have your 3x2 plus your 3x3. then this one will be equals to your 3. Then at the bottom you had your minus 2 x1, then you have your minus 2 x3, then this will be equals to your minus 2. I've seen this question in the long form questions and also in the short form question where they ask you to do this in like an augmented form. As you can see, the normal order that you would have your x1, your x2, and your x3. So when you're going to draw your augmented matrix, do not make any mistake to place them exactly where they're supposed to be, and where you don't see the other ones, you just put your 0, because here you don't have your x1, you just put your 0. My status is off. Here you just put your 0, here you don't have an x2, here you're going to put your 0, then you solve your thing. So it means if I'm going to be writing this in an augmented matrix, I'm going to write my first coefficient, which is my 2, and then you have your 4, then you have your 2, this side you have your 0, this side you're going to have your 0, then you're going to have your 3, and your 3, your 3, your minus 2, your 0, your minus 2, and your minus 2. So they can also just like give it to you in that long section where they give you something like your 5 marks. It depends how they're going to ask the question. So now you see, if you manipulate your row 1 and your row 3, you can just like add them together. You will end up with a 0 in this corner here. Then if you have that 0, it means now you have that triangle that like we love to work with. Then you start solving your variable, your x1, your x2, and your x3 the way we were doing, because like remember, you're just going to start at the bottom at this side, that okay, you have your minus 2 x3, which is going to be minus 2, then you know your x3 would be equals to your 1. Then you go to solve the other unknowns. So yeah, it's just like they're just gonna twist things there and there, but like in most of the cases, do not be scared. You actually know all the steps. It's just like sometimes you become overwhelmed and you miss easy marks. Let me just erase this and do that. Then now it would mean that like you've already found your x3. Then this side, remember, what do we have? You can quickly go and write them at the top. That okay, this side we have our x1, this side we have our x2, this side we have the x3. Then now you can say you have your 3x2 plus your 3x3 is equals to 3. But x3 you've already, no, why am I writing x squared? This is x2. Then you know your 3x2 plus your 3 into 1 is equals to 3. Then now this one is going to be your 3 x squared plus your 3. This one will be equals to your 3. Your 3 cancels your 3. This one, why is it giving me undefined? Yeah, but like perhaps it's just gonna be one of those examples where you have, let me check if they wanted me to solve it further. No, they just wanted us to solve it in like augmented form. But like if it happens that like it's one example that can be worked further, you'll just like simply use this way, because now with this one is not going to be workable. This is going to have your 0. Then this side, it's this one, your x2, it's going to be undefined because you can't divide your 0 by by 3. But if should it happen that like it's one example that you can work it out, you'll just like follow the same steps that like we've done with the other one. Then I only see here, what were they saying? Write the system in augmented matrix form and use Gauss reduction to write in row echelon form, which is exactly what we've done. They were only interested in this one, which was for 2 marks. So the second step, I was just checking if these values are workable, but like it turns out they are not. So these ones, you can just like leave it here for now. Then another one that like they like to ask, which one was it? I think it was like an example. Okay, they were asking about like the system's inconsistent. So it was something like this. You have your 1, your 2, your 3, your 0, your k, your 5, your 0, your 0, your k squared, then you have your k squared minus 1. Okay, this side you had your 4, then you had your 6, then you had your k plus 1. Then yeah, something like this. Then the question was saying the system is inconsistent if like it was some sort of like a multiple, it's like MCQ questions. They're saying the system is inconsistent if, then in your A they've given you your plus or minus 1, then your B they've given you your minus 1, then you C, I can't even see this thing. What are they saying? Okay, your C they just said your integers, then your D they said if it's 1. Then yeah, before I forget, let me just quickly send all these questions to the group. You'll also try to attempt them. Then if you're struggling, you'll just like let me know. So before I do this, let me quickly send everything to the group. Okay, they're loading. You should be able to see them in a few. How many questions are there? So okay. It's not connected. I'll just like connect as we go. So they were saying the system is inconsistent if k, let me just like write it down. The system is inconsistent if k is equals to, then yeah, and simple if there's talking about something being consistent or inconsistent, it basically means, okay, let's just explain it in terms of the last row that you have this side, which is going to be this one. If this thing is consistent rather than inconsistent, it means we're going to be having a 0, 0, and also on the right hand side we're going to be having your 0. So it basically means your right hand side should be equals to your left hand side. So you can quickly go and solve for your k squared minus 1, which is this one that you see, and you try to see for which values are you going to get like the same results on the left and the right. Then you know you have your k squared minus 1, which is going to be your 0. Then you know your k is your plus or minus square root of 1, which is going to be plus or minus 1. Then you evaluate your k for all the values that you're going to get. So the first one, if we have k as a minus, let me just check. Okay, if we have our k as 1, it means here we're going to be having our 1 squared minus 1. No man, we're supposed to be checking on the other side. It means now we're going to be having, I feel like I'm repeating myself. Okay, we have k is equals to plus or minus 1 that we've got, but now we have to check that, okay, if we're going to input the minus 1 on this side, it means we're going to be getting a 0. Then with 1 we're going to be getting 1 plus 1, which is going to be 2. So now it means only, let me check. Oh yeah, so now it means our only answer that we're going to take. They're saying the k is inconsistent if we have our k, if a k is equals to 1, because now it means on this side, what are we going to get? We're going to get what? We're going to get that this side is k plus 1. We're going to get our 1 plus 1, which is going to give us a 2. And your 2, it cannot be equals to what's on the left hand side. Hence, the final answer we can say k is going to be inconsistent if our k is equals to 1, which is also there on the answers. And the answers, then yeah, that will be like that, your two marks. Then no man, I sent in the wrong group. Okay, let me just look for send it to the. Okay, they're loading now, they're loading. Okay, yeah, you'll get them. Then try to go and review those questions. Then the ones that like we didn't touch on, we'll just like include them along the week. Because like I was just thinking, I'm not even sure about the format because like I wanted us to at least during the week ensure that like we go and start again from unit 1 going up again up until unit 7, but now I'm just gonna at least maybe in each unit try to include like 2 to 4 questions that like are applicable in the exam. So yeah, a format like that one. Then I don't know, you guys will tell me because like I don't want it to be a thing where it can be on Saturday. But if you want, we can make it a Saturday and Sunday thing, or we can do 1 hour to 1 hour 30 each and every day up until Sunday. Because like if I say Saturday, the lesson might even take long, and like I'm not sure if everyone will be concentrating. So yeah, we'll just like talk about it at the group and see which one it's best. But for me personally, I just think if maybe we had like a lesson each and every day up until Sunday, then we cover everything, including the examples, the past papers, the questions that you have, then that would work. Because like if we could do it on Saturday, imagine if like we try to cover everything on Saturday and Sunday. Mostly our lessons are going to be long. Probably they will take 3 hours or more. But yeah, we'll discuss that in the group. Then for today, I think we can just like stop here. I'm also hungry. I'm hungry. So yeah, thanks guys for joining, and please remember to attempt the questions that like I've sent and the group. Anything else that like I've missed out, we'll just like include it on the other sessions that we're going to have. And for me on my side, I'm free to host sessions up until you guys right. Even if tomorrow you guys have something and you want me to host a session, we can do that. So I don't have a stress with hosting sessions up until you're right. Then yeah, it's just up to you guys. It's up to you guys. So let me just stop the